Thank you, Dr. Suchitra, Dr. Ramesh, and members of the Institute of Green Engineers. It gives me great pleasure to join all of you today. I hope you can see my PowerPoint presentation. Um, I'm humbled by all the comments. I hope I'm deserving. My background, as Dr. Suchitra pointed out, is not in engineering. And I think one of the things I like to see is the evolvement of unified fields of knowledge, which is what is not happening today. If you look back more than 100 years ago, scientists were known as natural philosophers. It was a philosophy that all subjects and nature could be explored was fundamental to that approach. Today, one of the things that's peculiar is that we've made advancements in many areas. However, we have uh, worked in silos, taken piece by piece approach to classify things as mechanical engineering, electronic engineering, and chemical engineering. The field of energy encompasses almost every known thing that you can think of, from Einstein's time modulations, space modulations, which is what we have introduced now. So given my background, it was challenging because about 20 years ago, I was taken aback when I was in Chennai and there was an incident called tsunami. It triggered something of a crisis within me to say, what was a tsunami? Why didn't I know about it? And I think that spurred a whole lot of thinking inside of me to say, I have to do something about it. Now, rather than saying somebody's got to do something, I decided that why not me? We've always challenged ourselves. And I think to me personally, it was a personal struggle in the last 20 years as I had to learn from engineering and many other fields. So today, my talk is actually rather obvious. Is energy everywhere? And everyone says yes. But because my background is in economics, and I wondered if energy is everywhere, is abundant, then why is price rising? Because there is a conflict of information which I felt we needed to address, and no one is really addressing this issue. So in my presentation today, I introduce my book, my concepts. Primarily, I want to introduce the basic concept of a switching battery and the node fusion technology, which I think are breakthrough technologies in a different way. And as the earlier speaker pointed out, Professor Mishra, it all comes from what is called awareness. Are we aware? And using these technologies, we have now created what we call a solar accelerator device, which I'll share today, and the smart battery switch, another patent that's pending. I've got a number of patents, and the main patent that has been granted in the US and India as well, and many countries around the world, um, relates to time modulations, and that's what I hope to introduce today. I hope to make it interesting, but at the same time, I think in introducing what I consider to be innovation, I think it requires a context or an awareness. And this awareness is going to be very important. So, one of the things I did differently as a natural philosopher looking at the overall context was the evolution of energy itself. And so, I'm going to point out first to be innovative really means destroying something old to replace with something new and different called an improvement. As a matter of fact, and since Dr. Ramesh pointed out that there's a keen interest in patents, and I think India deserves because it has all the knowledge. If I would only be able to share, I have the luxury of speaking today at 6 a.m. because it's in Singapore. I'm speaking from Singapore. I'm mindful that all of you are perhaps in India and different parts of the world. And I wondered how you all have struggled to put up the 24 hours, and I commend that to begin with. The improvement I'm looking for really requires historical development of context. First of all, the battery is credited with Alessandro Volta, but 2,000 years ago, um, there was a Baghdad battery, but they were not using the battery in the same context. So here I've noted the evolvement of energy, what I would call energy 0.0, is the use of fire, the caveman, Stone Age. Progressing to energy 1.0, which is the use of heat to produce steam to create electricity, moving on to energy 1.1, which is what we're doing today. If you look today, we are in 2024 nearly, and a lot of it, the red zone. Why we are facing climate change is because in the last 200 years, we have used a mechanical era thinking. All of the developments of the energy comes from the 18th and 19th century. It's mechanical era. What we hope to do in the switching battery is to bring a new possibility, and that is what we call Energy 2.2. The Energy 2.2 really is an evolvement of Energy 2.0. Basically, if you look at Einstein had something to do with this, the photons being used in photovoltaic panels to generate electricity. This evolved over the years with a marginal improvement with electronics. And what we hope to do is further through what we call the node fusion methods. So in the future, I hope to provide hope, and I think we have crossed our own limits, and we're looking to cooperate with many others in the industry because we are primarily more research based. So as I provide the context, it's important that we discuss why we say energy is everywhere and why is that conflict, because I went in search of this answer for the last 20 years. Yes, energy is all around us, but the answer lies basically why the prices are rising is because of the way we obtain. And this look at this fish in which says, I need water, it reminds us of us saying we need energy. Yes, we all need energy. And my hope is that we will embrace the fact that electricity is a necessity in the 21st century. And many countries in many parts of the world, we still do not have access to electricity. Because I do believe that if energy is everywhere, then so is electricity, in which case it ought to be affordable, it should be accessible and open. That will open up many other possibilities in terms of us taking even addressing water shortage because we can have water pumps. The question I ask is, why is it like the fish? We don't know that we are in water or we are in energy. To address this, we look at how we obtain energy. So the tangible energy is like wood, coal, we extract from the ground. And then there's solar and wind, which are intangible, which means it got to be harnessed. So there are two types of technologies. One is tangible, one is intangible. If you look at the extraction method, the extraction and transportation of fossil fuels cost money. What is happening now is we have to go further and further away. If 50 years ago it was 10 miles away from us, today we have to go 100 miles, 1,000 perhaps. Worse still, we have to go underground deeper and deeper. It costs a lot of money. If you look at it, we are actually wasting 67% of energy from fossil fuel in the conversion in power plants. Power plants burn more fossil fuel than we use as electricity. Why did we not address it? Tangible asset supply is limited and getting more difficult to reach, resulting in price increases. So it's the obvious I'm presenting, which is more and more inaccessible. We're not talking about climate change. We're just talking about being pragmatic and logical as consumers. Then we have the harnessing method. Renewable energy from the sun and wind is abundant, which means it's like air. We are not paying for air to breathe until it becomes scarce. That's pure economics. The problem, of course, in renewable energy, the take-up is low. There's only one fundamental reason. It is because of high upfront costs. I wouldn't bet on anybody and recommend anyone with the present technology to invest in solar technology because it does not make sense. And without government grants and subsidies, there's no reason to because we're getting reliable electricity from the grid. One of the things that the present method and the technology it has is that the technologies are fixed, resulting in over-designed systems, including the solar. So if you really look at it, in terms of the sun in one day can produce enough energy for 24 years. Now, let me put the facts in front of you. We can waste 99% of every day's energy because tomorrow we get another 24 years of supply. So we have a lot to waste, yet we have not challenged ourselves to say, why have we not solved this simple equation? It's a mathematical equation. We can afford to lose 99% of the sun's energy every day, provided we know how to harness it in the proper way. So in my research and in my patents, we looked at how we could tackle the weakness of this harnessing technology. And we discovered strikingly that, and here I'm going to pause a bit so that you can address this. Uh, the present harnessing technologies like solar charge controls and MPPT control the sun like the curtains. So in other words, we're saying we're not getting enough. So let's look at the facts. If you use solar panels, solar PV technology, in a whole day, you'll be blessed by getting 4 hours of power or energy, because the relevant period you get is probably after 10 and before 3 p.m. So within the 5 hours, you also have rain, clouds, and everything else. So what we are facing now is we have intermittency. Then we say it is therefore not reliable. Now, when I speak to many people in the solar industry all over the world, they say they do not want to use batteries. They want grid tie. So which means they do net metering. India is embarking on the same thing. But I tell them, look, the grid is much more wasteful because it's going to waste another 67% out there, or at least 10 to 20% in transmission. So what we found is the switch is in outside the batteries. So basically, you do not maximize the voltage. The MPPT or solar charge controllers are necessary because you can't have, and one of the things you find is there's an aperiodic irradiance coming in from the sun. Many factors attribute to this: cloud, dust, rain, all those things are attributing factors, which means although the sun's radiance is stable, the irradiance we see on the ground is not. We have not found a way to tackle this irradiance that we receive. So we have the devices that turns off at high voltages because the solar panels are usually oversized compared to the batteries. And next is the MPPT we have tested ourselves do not work. If you use a 12-volt MPPT, it needs to charge because it doesn't have batteries to begin with. So it does not work. Third factor is the MPPT, or what is known as the maximum power point tracking, maximizes power, not energy, for that moment only. And so we found that these are the three weaknesses in the present technology. To solve this problem, or rather the unknown problem, we found that actually the switch was on not on the desired side. We found that if you rather use the same technologies, and one of the best technologies today is the inverter for the air conditioners, they use what is called the PWM, or the pulse width modulations. When you use a similar technology, so in other words, conservation requires turning off. So you need to turn off whenever you want to conserve. I mean, there's no other way. But the present on-off switches are what I call 0-1 switching. What I've introduced is parallel series switching. I call them XY switching. X stands for parallel, Y for any number in series. X could be 4-volt, which is low voltage, Y being 8, 12, 16, 20, any number of voltage points that you can have. In other words, it's a new off system, but it's a sleep mode, which is what is being used in inverter technologies in air conditioners and fridges. That saves roughly about 30% already. And we have just merely taken that one step further. So what switching battery really is that we have incorporated switches inside the battery, which nobody has done until today. That is a fundamental change we made. But other than that, the technology remains the same. The second is we use parallel series switching and source load switching, which is enabled through our other technology called node fusion technology, which I'll address quickly. Now, awareness is the key in solving problems or issues. We have altogether seen the batteries as just two batteries, like here. There are two batteries. But when you use mathematical formulas in graph theory, you'll know that 2 points can only be connected in a straight line. So when you connect two batteries, you are fixed. So you either have parallel or series. You can't have both. But the moment you go one level deeper to the node and recognize that these two batteries have four nodes, the anodes and cathodes, two of each. So you have point 1, 2, 3, and 4. What you'll then find is you can have 4 points of connection, which enables you 3 different connections, of which 2 are relevant. The 2 relevant ones are parallel and series. So you can connect them both in parallel and series. One of the things I was taught in school in Singapore was that you cannot have parallel and series connection. I defied that by testing it over the last 10 to 15 years. And I found that actually you can, but using time or space modulations. And that is achieved easily with node fusion technology, which is this. So we use graph theory. In graph theory, if you're aware, we've actually borrowed from the internet and computers. Computers, internet all use graph theory. You use a series, you send packages of information in series. And then you have another coded message to know how to rearrange them. So we've borrowed all these technologies, recognizing that information is energy. It's just a smaller package. What we are doing now is expanding it into a larger scale to hopefully solve a greater challenge that we are facing right now. So what we are also doing is through the source load switching, we're converting from renewable energy to regenerative energy systems. And let me quickly explain. So using this K8 graph, we use node and supernodes in graph theory. The one on K8 graph on the top, I hope you can see the shifting. We connect 8 points. So you have 2 batteries. Now, one of the key things is you always need at least 2 batteries. It is a principle of duality, which I learned from India. Everything is broken down into Shiva and Shakti in that sense. So one is a moving force, one is an immovable force, and that is how the relative equation comes in. So using that, we've connected now in a more dynamic mode. What this enables is the future is an voltage modulation. So if you notice, we can now modulate in, say, if you have a number of batteries, say 10 batteries, you can now have, and each battery is 4 volt, 10 batteries will be 40 volt. You can have 36 volt if you want, 32 volt, 28 volt, any digital voltage you can have. The advantage is there is almost zero energy loss. And because we're using 2 methods, one is digital, one is a manual switch, which I'll touch on quickly. Another is more dynamic switching. If you use dynamic switching, then you have a loss of up to 3%. By using this, you do not require bulky transformers. If you have 84 batteries, which is what we're testing out now, you can have what we consider to be even devices to handle what is called inrush current. We're working currently on what is called the inrush regulator, because the normal air conditioner will require only about 8 to 10 amps maximum of normal current coming in. We provide 25 amps, which we think is unnecessary. Again, these are things we're developing currently. The one down here is our development board we are introducing in the next couple of weeks. This is the smart battery switch, which is my latest patent that is will be published in about 2 weeks' time. And this is how the development board looks like. In the middle, you'll find is the switch, which is for parallel and series. So you have dual voltage here. Right now, it's at the lower voltage, discharging at 4 voltage. And now we're switching over for the LED for 8 voltage. These are lithium-ion batteries. The useful thing is that it's got MPPT algorithm built inside of it, so which means we can harness the energy of the sun, and that's what we're introducing in India next month. Our first product will look something like this here, and it's coming out. It's a light that will cost hopefully about 1,000 rupees, but it's actually also a study lamp, 1,200 lumens. It can last at a low voltage for 18 hours. Basically, it's mimicking the iPhone, and I'll touch on that briefly afterwards. So the smart battery switch is the first product to be introduced. It replaces what is called the quick break mechanism invented by John Henry Holmes in 1884. So we notice what we are doing is we are going and again, context, I had to study the history of switching, where switches evolved from. And I discovered that we continue to use the same old switch. And let me be clear what this current switch is, invented by John Henry Holmes. Instead of going to sleep at night, he says you have to be dead. That means you go into zero heartbeat. It's impossible for human beings. So basically, as a natural philosopher, one of the things I did about 10 years ago after I had my heart attack was investigate my own heart. And I discovered that actually the greatest invention is our human body. And I duplicated what is our lungs, the two lungs. That gave me the idea that, our lungs are the clue, are the batteries of life. And we don't die every time we go to sleep. We rest or we charge. The charging is important. So the new off switch is what my smart battery switch entails, is enabling charge at parallel. So what that really means is this product, which I just showed you earlier on, uh, it'll charge in about 2 hours from the solar directly. Whereas typical solar will use 18 volt to charge 12-volt battery systems. The solar panel we use is small. It's only 24 watts, 6 volt, 4 amps, and it's very neat in a sense. The next product we're introducing is a solar accelerator device. This is the actual image we're testing still. It'll take another 2 months before we release this product. It's fairly complex in its circuitry, but the principles are fairly basic. It replaces the MPPT. It replaces the solar charge controllers, voltage regulators. It replaces the battery management system, and it provides a UPS as well inside. So it doubles solar energy generation. It can generate even at low voltage or low irradiance, using what we call a new SINGA protocol. The SINGA, I'm from Singapore, so I had to name it after Singapore a little bit. SINGA stands for Solar Integrated Next Generation Architecture. We're introducing the SINGA protocol. This protocol challenges Qualcomm's protocol. One of the best protocols you can have today on charging structure is the Qualcomm. We are looking at all ways and means to compete with Qualcomm's protocol. Instead of BMS, we use a new charging methodology. It's called integrated charging and balancing. I have another patent just on that as well. The best advantage of this technology is that it uses throughout a 6-volt solar powerhouse. Typically, everyone uses 36, 37 volts large systems. What we are doing right now is using 6-volt, and you can now increase the amps. You can use 1 amp, 2 amp, 4 amps. We're trying to go higher amps, and that's what we're doing now. And the other final neat thing is this technology enables what we call solar watt peak shifting. Now, the solar industry over the last 30, 40 years has operated on a default gold rule, which is called solar watt peak. All tenders are given based on solar watt peak. Today, we are finding that with this new technology, we can shift the solar watt peak to battery because it is an isolated load. The final discharge comes from the battery. The solar enables the charging of the battery itself. This is our solar accelerator device. Which will come out, we hope, in the next 3-4 months with the switch inside the battery. So what we are doing right now is we're introducing this smart battery switch in Chennai in July. That's the one I showed you earlier on. The solar accelerator is a tentative. We're still doing testing. We recently started testing on larger systems. The one you see in our research center in Chennai near the airport and my team of engineers down there. Our larger system, we're beginning to test. It'll take at least another 3 to 6 months to test out these systems and larger innovations. Finally, coming to where the advantage is, where we see solar innovations going, is providing reliability through our system, because one of the biggest areas we're trying to address is the reliability is very important. So our systems roughly peg out to about 4,000 compared to a system which may cost about 16,000. And of course, we use a new solar tracking tripod, which I'll show you on my next slide. It's quite an interesting thing. So Our solar panels, the advantage is they're small. It's almost plug and play with our device. This picture shown down here is the dual voltage, 12 volt and 4 volt output, and it charges in 5 volts. Again, it charges relatively quickly, and we hope with this new tripod solar that we are still working on. Again, because it becomes smaller today, you can now have stepper motors and all we're introducing and trying to see making them much more appealing to the younger audience, especially. So we're instead of balcony solar, which is introduced in Europe, we are trying hopefully to come up with what we call tripod solars. So the tripod alone is more expensive. With the tracker, it'll cost more than the solar panel itself, and that's again for a different market, probably in the U.S. market. Now coming to what we have solved, we believe is reliability is very important. We use solar. We hope that that's where the direction is going to be. We've also believed that we've addressed what we think is the affordability problems so that it becomes affordable. And it's all enabled through this simple technology, which we think is not very expensive. So we hope that we can work together with many institutions. We hope to work with iGen. We hope to work with many universities in India. We are right now moving into training and development because this technology requires people's ability to work together with us. We have education licenses. We're working again. And finally, of course, this is my final slide. The one you saw earlier on is actually meant for your phones. This technology was inside your phone. You can say, like my iPhone, you can actually charge it using a solar directly. And again, we hope that many companies will be excited about this development. I've come to the end of my presentation. I hope I've been useful. Thank you.
Really, thank you so much, sir. I have one quote now. The starting point of all achievement is desire. I hope your speech will be the starting point for saving the energy. You have keynoted energy evolution, solving unknown problems, and reliable, affordable, and sustainable. It is not together. It is not the other person should think of it. Each and everyone should put effort. Individually, we have to put forward to save our energy. So if you want to, which made you to think of like this, saving energy? What is the motive behind that?
My children. I wanted my children as well as your children, everybody's children, because I felt that I'm today 62 years old. So I started this journey 20 over years ago. Perhaps it was a midlife crisis when I saw tsunami. I saw many things happening, not only in India and other parts of the world. I felt that the younger people should have the best opportunity to live in a beautiful planet. I was born in a beautiful planet in 1962. When I visited India, I was born in Singapore. Singapore was very beautiful then, and Madras, as it was then, was a beautiful place. Today it's congested. I hope that one of the things we hope to do is bring this back home to villages so that villages will start prospering instead of everyone coming to cities and overcrowding it. I find from Chennai to many places are being overcrowded. And I hope that by localizing such community grids or empowering people. So I wanted basically to empower not only myself, I wanted to empower everyone who felt that they were not good enough. And so my challenge always is to help people who want to better themselves but do not have access to that kind of guidance. And so I took the challenge that I had to lead by example. It was a challenge. I'll be very candid about that.
You're not an example, sir. You're an inspired person, and by your speech and by the way you communicated about the savings energy and how you have utilized the solar. So everywhere, as you mentioned, starting itself, energy is everywhere. From the starting point, in all streams, you have implemented this solar. Really, it's a awesome session. Our young generation has made use of it. Really, thank you so much for making use of this valuable time. You have spent your valuable time with us for sharing information, whatever you have gained it. It is one point you have said, sir, contact and connectivity. Yes. I hope this connectivity will be the starting point to spread all the information in one platform. So contact and connectivity is very important for each and every individual person. This session made every young generation an eye-opener session to save energy from this day. Thank you, sir. Thank you so much.
Thank you. Thank you, Dr. Suchitra. One final thing, if I can add, is, I think, there's Latin statement, sic parvis magna, which means start small, it'll grow big. I did not think big. And I think the fundamental mistake people and students try to do is they all want to be big, yes. But I think if every day you take a 0.001% improvement, I think it's a great thing. And my journey 20 years ago started with that. And, I think patience and faith is one of the most important virtues that I think I've embraced in this journey.
Thank you so much, sir. Thank you.
Thank you.